This question says, evaluate the following function at the values of 6, -1, and x minus 2. And our function is f of x equals x squared plus 1. So let's start evaluating at 6. So for x equals 6, f of 6 is 6 squared plus 1. So everywhere I see an x in my function, I'm changing that value to 6. 6 squared is 36, and 36 plus 1 is 37. So to evaluate the function at x equals 6, we get 37. F at 6 is 37. And let's do it at x equals -1. F at -1, everywhere I see an x, I'm going to change that x to a -1. That's going to give me -1 squared plus 1. You'll notice I put parentheses around the -1 because I want to make sure that I am squaring that number, the whole number, and not just the whole number including the sign and not just the number part. -1 squared is a positive 1, and 1 plus 1 is 2. So we found that at x equals -1, our function is 2. And then our last one, we want to evaluate the function at x minus 2. That means we're finding f of x minus 2. Everywhere we see an x, we're going to change that to x minus 2. So we have x minus 2 squared plus 1. Once again, I use parentheses because I want to make sure I square that whole thing. And when I simplify, this becomes x minus 2 times x minus 2 plus 1. Squaring something means multiply by itself. We're going to multiply that out to get x squared minus 2x plus 4. Carry down that plus 1, and we'll combine like terms. That's x squared minus 4x plus 5. So the function at x minus 2 is x squared minus 4x plus 5. This question says use the graph of y equals f of x to answer the questions. For how many values of x is f of x equals -3? And what is the value of f of 2? Let's start with part A. For how many values of x is f of x equal -3? So we have to keep in mind that f of x is the same thing as y. So what we're really saying is how many values of x has y equal to -3? So to figure that out, I can go on my y scale to where y is equal to -3 and draw a horizontal line. And I want to think about how many times that horizontal line is crossing the graph. So this is the line y equals -3, and I can see right here I have a point on the graph, so there's one x value of -1. Here's another place where it intersects the graph. That one's not labeled. We could make a guess about it. It looks like it's about -4. And then we have one more place, and I'm going to erase here so we can see it more clearly. We can see that that's an open circle. And the open circle means that that's not part of the graph. So even though it's labeled on my picture here, because it's labeled next to an open circle, -9 doesn't count as a point on this graph, -9, -3. So we have two places where f of x equals -3. two x values where f of x is equal to -3. So that's how many values of x, two values of x have y values that are -3. And for the second part where it says, what is the value of f of 2? We have to remember what this notation means. F of 2. 2 is my x, and f of 2, so this entire notation here, is my y. So what's asking me? It's asking me to say, what is the y value when x equals 2? So I'm going to go to my picture. I'm going to find an x value of 2, and I'm going to go over to the graph to see what that y value is. And that y value is -1. So f of 2 is -1. This question says, for what value of x is g of x equals 7? So we have to remember that the notation g of x is representing y. So this is saying that y equals 7. And the question says, for what value of x is y 7? So we're going to go up here on our y scale, and we're going to find out where we have a y value of 7. We have a y value of 7 here. So if I go across on both sides, the only point on the graph that has a y value of 7 is right here, and the x value that matches that is -7. And so x equals 7, I'm sorry, -7 is when g of x is equal to 7. This question says, determine if the relation is also a function. Give the domain and range of the relation or function. So in order to determine if the relation is also a function, we need to remember the definition of a function. So for a definition of a function, every x has exactly one y. So as I'm looking through this relation, what I want to focus on the x's, I want to make sure that those x's have exactly one y. To do that, I'm going to look for the x's to see if they repeat. So I have an x of 9, I have a different x of 5, a different x of 8, a different x of 1, a different x of 3, and a different x of 4. So those x's never repeated, so we don't have one x relating to more than one y. We can also build a chart for the domain and range and show the relationship. So we can write down the elements in the domain to be 9, 5, 8, 1, 3, 4. If the element in the domain ever repeated, you would only write it once. For the range, we have values of -2, 0, 6, 4, 6. So since that 6 repeated, we're not writing it again. And then 2. And then we would draw connections between these values for every ordered pair that we have. So we have an ordered pair of 9, -2, so that corresponds. 5, 0, 8, 6, 1, 4, 3, 6, and 4, 2. So if you're trying to determine if you have a function, you're going to focus only on the domain values, not the range values. And what you're looking for is how many connections each x has. Every x should have exactly one connection or one y value. So this 9 has one connection, 5 has one connection, 8, 1, 3, and 4 all have one connection, so we would say that this relation is a function. And then we want to state the domain and range. So we're going to use our curly braces to list the items in the domain. That's 9, 5, 8, 1, 3, 4. We separate those items by commas. And for the range, we'll also use the curly braces. -2, 0, 6, 4. Remember, we don't write the 6 a second time. We just write it one time when you write it in the set. And we have our range. This question says, classify the given function as a polynomial function, a rational function, or a root function, and then find the domain. Write the domain in interval notation. Our function is f of x equals 4x to the fifth minus 3x, which is a polynomial function. So I thought I'd pause for a minute to make sure you understand what a polynomial function is. A polynomial function is one of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus ... meaning the pattern continues until you get to a sub 1 x plus a sub naught or a sub 0. And this is where n being that power on the variable, n is a non-negative integer. So remind you what non-negative integers are. Those are 0, 1, 2, 3. Those are our counting numbers. So the counting numbers are what's allowed in our exponent. And the coefficients, a sub n minus 1, and so on, these coefficients that are attached to the variable, those are real numbers. For practical identification, you're looking for the variable to be in the numerator. So if there are no fractions, like our example here, we consider all of these terms to be in the numerator, even though we don't see a fraction, because we can always create a fraction by dividing by 1. So we consider those terms to be in the numerator. The variable should not be inside a radical or absolute value, and the powers should be whole numbers. Whole numbers are our counting numbers here. 0, 1, 2, and so on. So if we look at our example, on our variable x to the fifth, 5 is a non-negative integer or a whole number. And on the other term, x with no power, we assume that power to be a 1, and that is also on this list. So this is a polynomial function, and what's really nice about polynomial functions is that there are no restrictions to the domain. We're allowed to substitute any value for x, so since there are no restrictions, our domain will be all real numbers or negative infinity to infinity. So there's not any calculation needed to find the domain of a polynomial function. You just have to be able to recognize when you have a polynomial function and understand that there are no restrictions and the domain will be all real numbers. Thank you for checking out my videos. Have a great day.